What if you have data given to you like this? All right? So this is fantastic when you have raw data, and I love it, and it's great. It's fantastic. But it's also, unfortunately, a little bit fictitious, because very often, instead of getting raw data, you're going to get, oops, right? You're going to get grouped data. PDX data. PDX marathon data. Can you guys find the average and the sample standard deviation of the age of the runners in the 2009 Portland Marathon? Can you find it? Not by hand! Sweet Jesus! There's like 500 runners in that I got in this sample. Can you find it? Say hell yeah!
Yeah, hell yeah.
There's one hell yeah. There we go. Yeah. You're like, I'm guessing the answer is yes. Yes, we can use technology to do this. There is a formula. I'm never going to teach it to you because it's ludicrous. You need your TIs though. You need your TIs. Clear them out. Go back to your stat editor. Go back to your stat menu. Go back to your stat menu. So your stat button, then your editor. Now, all that beautiful weight loss data is beautiful. Clear it. Make it go away. Clear and down. So now we're back to just a blank sheet. We need to fill this with some data. But if you try to enter this into your TIs right now, you're going to run into a bit of a brick wall. Because the first data point is what? 17 to 26. And if you try to type in 17 space TO space 26, your TI is going to get upset with you. It's going to give you an error. It's going to say error syntax because it doesn't like that. So what do we have to do? Think old. Think old news. You've got all these ages. The ages are over here at 17 to 26, 27 to 36, 37 to 46, and so forth and so on. We dealt with this before, didn't we, friends? Say that again?
You just pick it up in between them.
Yes! Here's the frequencies. Get the frequencies here too. There's 44 of those kids. There's 107 of those. There's 141 of those. 106 of those. 46 and 4 of those. We immediately, and Kate was very upset about this back in the day, we immediately lose precision like this. We know there are 44 people in this race between the ages of 17 and 26. And we do not know how many 17-year-olds, how many 18-year-olds, 19-year-olds, and so forth and so on. So what do? What's the only thing we can do? You find the average of the endpoints and use the middle. You find the number that's directly between 17 and 26, which should be 21 and a half, I think. Check me on that. Up and down forward. I think that's right. Add those and average them. Add them together, divide by 2. 21 and a half. And the trick is, you leave the half in there. Don't call that 22 or 21, because if you call that 22, you're going to be slightly overestimating the average. And if you call it 21, it's slightly underestimating it. So we're already losing precision having to do this. Let's not lose even more by doing a mathematical error. Fair? I should probably swing the camera this way so you guys can see what the hell we're doing. Here we go. 27 to 36 should be 31 and a half. I think these all break down to 1 1/2. Yeah, because they're 10 off. That should be about right. For those of you that are still upset about this, about the whole idea of taking the halfway point, I made a video for you guys. I linked it into, I think, this Measures of Center homework page that hopefully puts your mind at ease with 2 or 3 different data sets. Grabbing the averages, grouping and grabbing the averages raw and comparing the averages, and they're never off by more than a couple tenths. Okay? This, friends, is what has to go into our TIs. That has to go into our TIs. So how many lists are we going to need? We're going to need 2. This goes into your L1, and that goes into your L2. So take your time. Take your time and enter it. Please.
Are we going to need 3 because we're going to do FID?
That's the best part. We don't have to. Thank you, Michael. Michael is saying, wait a minute, brother, we need 3 because the next thing we're going to have to do is do X times F and then sum X times F. The TI does it all for us. Yes, the 82s did not. Back in the day, they did not. Nowadays, they've made them smart enough with a simple command, we can now make it do all that math for us, which is fantastic. And the reason it's fantastic is the variation formula for sample standard deviation of group data it's a nightmare. And I think we need 5 lists in order to do that with the tables. And it's just such a huge boom when the 83s finally went to a more logical data collection strategy. So thank you for that, but we don't have to worry about it. All right, let me take the time. Am I doing this right? 30? Yeah. Are there any 80s? No, 71's the last. Okay, let's go back up here. 107, 41, 106, 46, and 4. One thing, just a technological kind of caution to think about. When you enter data grouped like this, be real careful that you have the same number of numbers in L1 as L2. One of the more common annoying errors on the TI is called a DIM mismatch, D-I-M. That comes up when you have different numbers of numbers in your list 1 and list 2 and try to get the TI deal with it. So just so you know, that's one of the things you have to kind of work with. Now, when we did the weight loss data, I actually had you do that completely backwards. I had you calculate the average, calculate standard deviation, then talk about them via the use of standard deviations, and then finally, at the end of the day, graph the damn thing and look and say, oh yeah, it was okay to use that because they were bell-shaped. That's actually exactly the backwards of what you should do. You should graph it first, look to see if it's bell-shaped, and then decide, okay, it's okay to use the average. So I'd like to do that right now. Make me a histogram of our new data. And we'll go through the steps again. Here are the steps. You have to get to zoom 9, but if you press zoom 9 right now, I love that. Everybody press zoom 9. Thank you, Natalie.
Okay.
Press zoom 9 right now. No, thank you for that, friend. Thank you. This is good. Pedagogical moment. I love it. There's our data. But it looks weird. Doesn't look right. It doesn't look right. Can anybody know why it's not? It's graphed something. Why is it not right, Megan?
Because it doesn't have L2 in there also.
When we graphed raw data, do you remember when we set our graph up? There was a choice at the bottom. It said X list and frequency. Frequency was set to 1. So what it is graphing right now is it is graphing 121.5, 131.5. That's the bar at the end. The next bar is a 41. The next bar is 51. The next bar is 61. The next bar is 71. The frequencies are gone. So we have to fix that. Thank you, Natalie. That was beautiful. Second Y equals. It's almost right. We just have to make that one adjustment is all. Okay, you ready? Plot 1. Yes, I do want plot 1. Everything is perfect except for that. That needs to be L2 because that's what the frequencies are in L2. Make sense? That's the only difference. Everything else is fine. Your data's still in L1. Your frequencies are in L2. So we're going to change that to second 2. There we go. Now graph it. Zoom 9. That makes a lot more sense, doesn't it? That makes a lot more. It's a little bit gap. Get in there.
I got the dim mismatch.
Oh, the dim mismatch. Let's take a look at why. This happens. Dim mismatch happens. Let's take a look. Let's take a look. L1, L2, stat edit. Oh, you're missing one data point. 44, 107. One of these guys in here you're missing, it looks like, Jenny. Oh, yep, go ahead and add him in. So now you can actually see the heights of those bars. And if you can't see them, you can hit trace and move them around. I encourage you to finagle and try to get the bars to be wider, narrower, fewer, more of them. It's up to you. I mean, honestly, it's up to you to finagle. The main idea for me is to hit the graph and graph it and go, oh yeah, it's bell-shaped. And once it's basically bell. Dad, go ahead. It's basically a bell shape. You've got a little bit of a tail over here, but I can live with that. I can live with that. It's not, the tail's not way over here. I don't have Yoda running the Portland Marathon. Okay? So I can live with this. I can live with this. Now what I want to do is, once I have the actual shape, and I say it's bell-shaped, now I can take the average and feel confident that my average is not going to be misleading because it's too high or too low. And that's what I want to make sure you guys can do too on this thing. Find the average and the standard deviation in years. So go back into your stat menu, just like we did a couple times today already. Stat menu, over to calculate, exactly right, my friend. And as much as you want to, don't go for number 2, because it's still number 1. That might seem kind of weird, right? It might seem kind of weird, but it's still only one variable. What are we measuring in this data set? Age. One variable of age. That's it. It seems like there's 2 data sets, but this one is not data. The F column is not data. It's the number of data points. So it's not data, it's just a count. It's a shortcut is what it basically is. It saves us from having to write 21.5 44 times. So it's a shortcut. Okay? So it's still one variable statistics. But what you don't want to do right now is press enter. Well, what the hell? Press enter. It'll give you an answer. But it won't be the right one. Whoever said that was 100% correct. It will not be the right one. How come?
You want to include?
Yes. Do you remember the histogram when we graphed? And that first histogram only had 6 data points represented? What it just did was it just averaged L1 and totally ignored the number of times L1 occurred. So it now assumes there is one 21.5-year-old, one 31.5-year-old, one 41.5-year-old, and so forth and so on. So the way around this is to start again, stat, calc, 1 var stats. And here's the key sequence you want to use. Second L1, that tells the TI, okay, my data's here. Now hit the comma button. Comma button's right above 7. Got his own little button right there. And then hit second 2 for L2. What this tells the TI is, yep, my data's there, but count it this many times. You see what I'm getting at there, friends? That's what you have to do. And Michael, this is the shortcut that it takes care of for us. Go ahead and press enter. There's a difference in the averages now. And a difference in the standard deviation. Standard deviation is much, much smaller because more of them are clustered around the mean. So now, on average, a Portland Marathon runner is about 42 years of age, plus or minus around 12 years of age. And because the data is bell-shaped, we can now go in and report on that, can't we? Within 12 years up and down from average, there are 2/3 of the runners are basically in there. 19 out of 20 are basically within 24 years of average on your side, and almost all of them are within, 36 years up and down. Again, if you get too far out, 1 standard deviation is generally frowned upon as too narrow, and 3 is generally too wide. 2 is kind of like that. Was that Baby Bear in the 3 Bears? 2 standard deviations, that's the Baby Bear. That's the Baby Bear. It's just big enough, but not so big to lose complete and total accuracy. It's a nice range of values. Cool? So now you can deal with bell-shaped data when it's raw. Weight loss data. You can deal with bell-shaped data when it's grouped. What happens if you don't have what? What happens if you don't have? Be loud and obnoxious. Well, you don't have bell-shaped data. I think we can generate some.